Hey, what's up, everybody? Swarsky here. Go ahead and get to page 29 in the packet. We are going to start getting into law of sines, aka non-right triangles. Now, there's two methods for it. This is the first to be able to do that. And we are not necessarily going to be solving like we have been with trig. We're going to be applying trig properties and relationships to be able to solve. So that's going to be the big piece. So make sure you're on page 29. I do have one part before, and that's going to be kind of where this comes from, just so that you can kind of see that this isn't being pulled out of nowhere. Okay, so this is obviously non-right triangle. I say, well, how do I get a relationship with trig? Well, if I make this a right triangle, so let's say this is right, and I'm going to give some names for this. I'm going to call this, since big A is here, I'm going to call this little a. And then for this being C, I'm going to call this little c. Okay, and then this height here, I'm just going to call that X. Okay, and I'm just going to start with these two relationships and see what we can do. Now I'm going to try and find this. And we're just going to kind of start applying some stuff here. So let's use our sine, let's use C and let's use A. So let's use this from this angle and from this angle using our right triangle. So if you look, I have an opposite hypotenuse. So that's where I have the sine of, I'm going to call it C, equals opposite hypotenuse. And I'm going to do the same thing with A, where I'm going to see sine of A. Well, that's X opposite hypotenuse, X over C. So you see I have some things that kind of match up. Now let's just kind of play around. Let's solve for X on both of these. If I do that, I multiply by A, so I get A times sine C, and that equals X. And then if I do the same thing here where I multiply by C, I get C times sine A, and that equals X. Well, look at what we got here. Both of these are equal to the same thing. So that means I can set them equal to each other. So that means I know that A times sine C is equal to C times sine A. Well, let's move some stuff around. If I divide by C and divide by A, that moves C over on this side, A on that side. So now look what I got. Sine C over C is equal to sine A over A. And that's the basis for law of sines, because I can do the same thing. I can move some stuff around and get B in there as well. And that's what this is, where I have sine A over A, sine B over B, C over C with A. These are all opposite. That's how we label opposite, right? So if I have big A, that means little a is opposite. If I have big B, that means little b is opposite. If I have big C, that means little c is opposite. All that's referencing is that we're talking about the opposite side. Okay? So the angle, the sine of the angle and the opposite side have a ratio together. So what it's saying is that the ratio of the sine of this angle, the sine of this angle over that opposite side is the same as this angle over that opposite side is the same as this angle, this ratio over that side. Okay? So we're going to use this, and we should be thinking we're dealing with proportions and ratios again. And even though there's three of these, we're really just going to have a relationship of two of them. Okay, and we don't have to write everything. I'll show you kind of what it is. But the idea is that all of the side and angles and sine ratios of the angles have a relationship. So you see, we're not actually finding the ratio of sine. We're using the property and the relationship of the sine of the angle and the opposite side of a non-right triangle. Okay, so let's see what that looks like. So we have here, and this is going to be the kicker. I know if I'm going to use law sines. I know if I'm using law sines here. If I have a ratio, that means that I need an angle and an opposite side. This is the giveaway that law of sines is going to be used. Okay, it's going to make more sense when we start doing law of cosines. But, so here's what that looks like. So if this is A, right, this is A, little a, and I say, well, what else do I have? Well, I have B. I'm going to try and find this piece, okay, which means I have this relationship. Okay, so I'm going to say, when I do this, I'm going to say the sine of 65, that sine ratio is over the opposite side is the same proportion or the same ratio as this over the side I don't know. Okay. Now I'm simply going to be solving. You say, well, how do I solve that? Well, you'd use the principle of solving for x, or another way to say it is cross multiplying. And it might look a little weird, but here's what that looks like. I go, so x times sine 65 is just that, x times sine 65 equals, and I'm going to leave all this stuff until the end, just so it's not rounded, 80 times sine 85. And I only have one more step. I say, well, how do I get x by itself? Here, sine 65. This is everything that goes in to my calculator. Parentheses would probably be a good idea on this case. Okay, so when I put in my calculator, I go parentheses 80 times, now be careful because it's going to give you parentheses to start with, sine 85, and the parentheses, and then divide all of that. You're going to see something like this, sine 65. Okay, if I do it in kind of the right order, your calculator is going to take care of the order operations. It'll do the ratios, it'll have the decimals, do all that stuff, and it'll be finally solved beforehand. So I don't want to know what sine 85 and sine 65 are now, because it'll just round it. The more I round, the more it'll cause problems for me in the end. Okay, so if I plug that in, so why don't you try that, and let's see if you get what I get. Should get 87.9 for that length. And that, what we just found, is this, which should make sense. If this is 65 degrees gives you 80, you'd imagine that this would be bigger, right? So that's a nice little kicker for that. All right, let's see if you can handle another one with sides. So try this one out here, and then we'll come back and we'll see what you do. Okay? All right, so again, here's the relationship I'm looking for. I'm trying to find AC. So that means I would set up sine 55 over 98. That ratio is the same as sine 105 over x. Cross multiply, which means I'll end up with 98 times sine 105, x times sine 55, right? I'm just solving for x. Divide by sine 55. Here's what's going in. So I'd go parentheses, 98 times sine 105, divided by sine 55, should get 115.6 for my length. Okay. Now there are two more examples. There's solutions online if you want to check those out. I'm going to jump just so I'm not going to show all of these just for sake of time. So if you want to try other ones, you can do that. Make sure you got it. Double check the solutions, and then come back to the video here and you can do the angles if you want to. So we're going to jump to the angles, which means it's on the kind of middle of page 30. Because now same thing holds. You see that I got this relationship right here and here, but now I don't know the side. Okay, so that means I'm going to go sine of, let's say 70 over 17, but this time it's sine x of over 12. Well, what do I do with that? Cross multiply still. Okay, I'm going 17 times sine x, sine 70 times 12. Still solving. I'm going to divide by 17 here. Now you say, well, what the heck do I do with that? Well, remember, anytime I am finding angles, I do the inverse to be able to find this x. So all of this gets inverse. So I'd go sine inverse of all that. An easier way to do this is to get this first. Okay? So you get this and you have the answer. And then in my calculator, I get sine -1, and then if you kind of know your tricks for calculator, if I just put A and S, that just recalls the last answer, and it does the whole thing. okay? Or you can just plop in sine inverse 1, and it goes there, and then go through the process of doing that. It just saves you a little bit of heartache here. You should end up with, when you do this, 41.6, and this is degrees, okay? So let's see if you can do this last one here. Give that one a shot. Try it out. Off you go. All right. So here's my ratio here. Here's my side. I want this angle. So I'm going to go sine 108, 108, 184. That's equal to sine of I don't know, 109. Now, gut should say if this is 184 and this is 109, this should be smaller than 108, which makes sense. Okay? Cross multiply, which means now I'm sitting with, I'm going to put it all together. So I go 109 times sine 108. That'll all be over 184. This is all sine inversed. Okay, so sine inverse, all that stuff, and I'll end up with 34.3 degrees. Okay, mess around with your calculator. Also, I have some extra videos for you to check out just to make sure that you can get that. Last one. Oops. See if you can do it. So we'll call this success. It's adding a little bit to it. We are looking for angle F. Okay. The only hint I'll give you is that you might have to find this one first. Try it out. All right. So I have to kind of go work my way around. If I'm trying to find this, I can find this first, and then I can just simply minus these 2 by 180. So really I'm doing sine x over 9. That ratio is the same as sine 99 over 19. Cross multiply. Sine x times 19 times 9 times sine 99. And then I'm going to divide by 19. This gets inversed, right? Sine inverse all of this stuff. So I get x equal to 27, I'm going to round this one a little bit, 27.9 degrees, which not what I'm looking for, because now I take this plus the 99 minus 180 to get there. So my final call is right around 53.1 degrees. Okay, so you can see now we're starting to get to the point where we can find any piece of any triangle that we want. Okay, practice for you. Page 31 and 32, it's just core, nothing else super crazy. No extended or skills. All of it's required. Get your practice in, try your stuff out, check your solutions. Let me know if you got questions, and I'll see you on the next one, everybody.